All right, let's talk about something every scientist knows all too well, that feeling of being completely buried in a sea of lab data. Well, in this explainer, we're going to tackle that head on. We're going to dive into Origin, an incredibly powerful piece of software that's all about turning your raw numbers into beautiful publication-ready figures. So let's get right into it.
You know the feeling, right? You've spent days, maybe even weeks, at the bench, you've run your experiments, and now you're just staring at this mountain of spreadsheets. It's overwhelming. So the big question is, how do you even begin to make sense of it all?
That's exactly what we're going to cover. We're going to show you how to take that chaotic jumble of raw data on the left and transform it into a clean, compelling, scientific story, something that looks like that polished graph on the right. Totally perfect for your next big paper or conference presentation.
So, why Origin? I mean, you could try to wrestle with a general spreadsheet program, sure, but Origin is different. Think of it like Excel, but if Excel went to grad school, got a PhD in chemistry, and started hitting the gym. It is built from the ground up specifically for scientific analysis.
And this is what I mean by supercharged. You get incredibly powerful tools designed for exactly what you need to do. We're talking about advanced peak fitting for any kind of spectroscopy, really robust statistical tools, and, this is a big one, automation features that can literally save you hours of boring, repetitive work.
Okay, enough talk. Let's get our hands dirty and see just how fast you can go from a spreadsheet of numbers to your very first graph in Origin. You'll be surprised at how easy it actually is.
So here's some super common data you might get straight from a spectrophotometer. We've got our wavelength, which is going to be our x-axis, and the corresponding absorbance, which will be our y-axis. Pretty standard stuff.
And watch how simple this is. You literally just paste your data into the workbook, select those two columns, and then tell Origin you want to make a line plot. And boom, in seconds, you have your initial spectrum. It is that straightforward.
And hey, here's a little pro tip for you, a real time saver. You're going to be comparing multiple data sets all the time, right? Instead of clicking around to hide and show different lines, just hit Control-L. It instantly toggles the layers on and off. It's a game changer.
All right, now let's get into one of Origin's true superpowers, especially if you do any kind of spectroscopy. We're talking about peak analysis. This is where you really start to dig in and find the hidden story your data is trying to tell you.
But let's be real for a second. Raw data is almost never clean. Your first plot probably has some background noise, maybe a wobbly baseline from the instrument. All that junk can seriously obscure the results you actually care about.
So, first things first, you've got to clean it up. Before you can do any meaningful analysis, that noisy baseline has to go. Origin has amazing tools for this. With just a few clicks, you can subtract that baseline and get a much, much cleaner signal to work with.
Okay, see? Now that the junk is gone, we can get to the good stuff. You can fire up Origin's Peak Analyzer, and it will automatically scan your clean data and pinpoint all the important features, in this case, your peaks.
And it doesn't just find them, it gives you all the crucial numbers. It instantly tells you the peak's exact position, your lambda max, its height, its width, and even calculates the area under the curve. These are the key values you need for any real quantitative work.
Okay, so you've found the key features in your data. What's next? Well, now you fit that data to a scientific model. This is how you level up from just seeing a trend to actually proving a scientific law with your results. A classic example of this is testing the Beer-Lambert law. You know, the one that says absorbance is directly proportional to concentration. So you'd make a few samples with known concentrations, measure their absorbance at that lambda max you just found, and then plot those points to build a calibration curve.
Now, when you tell Origin to do a linear fit on that curve, it automatically gives you the R-squared value. Just think of it as a score for your data, from 0 to 1. And what you want to see is a number really, really close to 1.0. That's a beautiful thing. It means your data is solid and you've reliably demonstrated the principle you were testing.
So you've done all this amazing analysis. You have a gorgeous graph that tells a clear story. But how do you get it out? You've got to export it for your paper or your presentation without losing an ounce of that quality.
And this is another place where Origin just makes your life so much easier. You get total control. You can export to vector formats like EPS or PDF, which journals love, by the way, because they stay perfectly sharp no matter how much you resize them. You can also save your whole graph style as a template, so all your figures look consistent and professional.
And just to give you an idea of the quality we're talking about, you can export your graphs at up to 600 dpi. That's incredibly high resolution. It easily meets the strictest requirements for even the highest impact journals, so your figures will always look absolutely crisp and professional in print.
You see, when you master this entire workflow, from importing and cleaning to analyzing and exporting, you're doing way more than just crunching numbers. You're becoming a storyteller, a visual storyteller. You're turning that raw, messy data into a compelling narrative that's ready for publication. So, your data definitely has a story to tell. The only question left is, are you ready to tell it?